We know beta particle and electrons are same. We know that beta particles is nothing but electrons. But still there are some difference between beta particles and electrons. What is the difference? The first difference is beta particle emitted during the radioactive disintegration come from the nucleus of an atom. An electron remain in different orbital outside the nucleus of the atom. And the number two difference is after emission of a beta particle, the mass number of the new element remain the same, but atomic number increases by 1 unit. An atom converted into a positively charged ion after emission of an electron from the atom. This is the difference, two difference between beta particles and electron. Now, what is mass defect? The difference between the sum of the masses of protons and neutrons present in an isotope and its actual mass is called mass defect, and it is denoted by delta M. Let the isotope is X, A, Z, where A is the mass number and Z is the atomic number. Where Z is the atomic number, that is Z means number of proton, and A is the mass number, the sum of proton and neutron. So number of neutron is A minus Z. Again, we assume the mass of a single proton is MP, mass of a single neutron is Mn. Therefore, total mass, the mass of the nucleons. What do you mean by nucleons? Actually, the proton and neutron as a whole is called nucleon, present in the nucleus. So total mass of the nucleon is M dash is equals to atomic number into mass of proton, that is Z into MP, plus the number of neutron A minus Z into the mass of a single neutron, Mn. Now, if the fixed mass or experimental mass or actual mass of that nucleus be Mn, then mass defect is equals to this total mass minus actual mass. We denote mass defect by delta M. Delta M is equals to M dash, that is Z MP plus A minus Z Mn minus Mn dash. This is the mathematical expression of mass defect, which is very important for nuclear reaction or nuclear phenomena. Okay. Now, what is nuclear binding energy? Nuclear binding energy always expressed as delta E, and the definition is the nuclear binding energy is defined as the amount of energy released when a given number of proton and neutrons combine together to form the nucleus, or it is the energy required to disrupt the nucleus into its constituent proton and neutron. Nuclear binding energy can be calculated from its mass defect using Einstein equation E is equals to mc square, where m is the mass defect and c is the velocity of light and vacuum. Therefore, del E is equals to delta mc square, where delta m mass defect is equals to z mp plus a minus z mn minus mn within bracket c square. Binding energy, if often expressed in MeV, mega electron volt, where 1 MeV is equals to 1.6 into 10 to the minus 13 joule. If the value of binding energy is greater than 0, the nucleus is stable. If the binding energy is less than 0, the nucleus is unstable. Stability of nucleus always depends upon binding energy. Now, nuclear fission reaction. What do you mean by fission reaction? Nuclear fission is the process in which a heavy nucleus splits into two lighter nuclei of almost equal size by the bombardment of slow moving neutron with the release of an enormous amount of energy and three or more neutrons. It was first noticed in 1939 by two German scientists, Otto Hahn and F. Stresemann. And the chemical reaction related to nuclear fission is 235 uranium-92 when it is bombarded with slow moving neutron 10. It produces almost equal size of barium and krypton, 14156 barium and 9236 krypton, and 3 neutron and energy. This energy is called fission energy. There are two types of nuclear fission reaction. One is uncontrolled and another is controlled. Uncontrolled nuclear fission reaction. In nuclear fission reaction, it is noticed that 3 neutrons have been produced from one atom of uranium-235 along with large amount of energy. Now these 3 neutrons can hit 3 other uranium-235 atom. Each of these again release 3 neutrons and huge amount of energy. In this way, it has become a chain reaction. If this is not controlled, enormous energy will be produced in a very short time, leads to an uncontrolled fission, which is the principle of atom bomb. The second one is controlled nuclear fission reaction. A fission reaction in which the number of neutrons participating in the fission in unit time is controlled by some means is referred to as controlled nuclear fission. We can control nuclear fission by nuclear reactor. So what is nuclear reactor? Nuclear reactor is a device in which a controlled chain reaction takes place to produce manageable amount of nuclear energy which is used to produce electricity. The first nuclear reactor was constructed by Italian scientist Fermi in 1942. What is the essential part of nuclear reactor? There are 5 parts. The first one is core. It consists of fuel rods made of enriched uranium-235. Second one is moderator. Moderators slow down the neutron produced in fission. It is made of graphite or heavy water. The third one is control rod. Control rods are prepared by cadmium or boron that absorb the extra neutrons. Fourth one is coolant. Water or pressurized carbon dioxide is used as coolant, as because enormous amount of heat is generated, so we need a coolant. And the last one is the concrete shielding absorbs the nuclear radiation. Nuclear fusion reaction. What is nuclear fusion reaction? Nuclear fusion is the process in which 2 light nuclei like hydrogen combine to form a heavy, more stable nucleus with the liberation of an enormous amount of energy. As for example, for 1H1, that is normal hydrogen, which produce helium plus 2 positron plus 25 MeV, and the second reaction is 2H1, that is deuterium and tritium 3H1, which produce helium plus 1 neutron plus 18.69 MeV. The hydrogen bomb is prepared on the basis of this principle of nuclear fusion reaction. Actually, fusion reactions are called thermonuclear reaction because extremely high temperature, as for example 10 to the power 7 degrees centigrade to 10 to the power 8 degrees centigrade, that is 1 crore degrees centigrade, is required for fusion reaction. It is near about 200 million Kelvin. The principle of solar energy and energy of star is the fusion of hydrogen nuclei producing helium nuclei with tremendous amount of energy. Discuss about the numerical problems related to alpha and beta particle emission. The first problem is how many alpha particles and beta particles will be emitted for the following reaction. A 23892 and the product is Z 20682, where 238 is the mass number and 92 is the atomic number. Here the 206 is the mass number of Z and 82 is the atomic number of the product. We have to find out the number of alpha particles and beta particles will be emitted in this reaction. First, mass number is reduced by 92 to 80. Mass number is reduced by 238 to 206. So 238 minus 206, 32 unit. Therefore, the number of alpha particles emitted is 32 by 4 is equals to 8. If 8 alpha particles are emitted, then atomic number has been reduced by 8 into 2, that is 16 unit. But here atomic number has been reduced by 92 minus 82, that is 10 unit. So 16 minus 10 or 6 beta particles will be emitted. Therefore, 8 alpha particle and 6 beta particle will be emitted from A 23892 to form Z 20682. The second problem is what is the mass number and atomic number of the new element that is produced when 8 alpha particles and 6 beta particles are emitted successively from the nucleus of 238 uranium 92. Since 8 alpha particles and 6 beta particles are emitted successively from this nucleus, the mass number of the new element is 238 minus 48 is 32, that is 206, and the atomic number is 92 minus 8 into 2 plus 1 into 6, that is 92 minus 16 plus 6. Why we add this 6? As because the 6 beta particles are emitted. So the atomic number increased by 6 unit. So the new atomic number is 82. There are some reaction in this way. We have to complete the following reaction. As for example, radium 22688, it produces radon 22286, and there is a question mark. What is the product? Actually, the product is helium. Again, in C146, the product is nitrogen 147. What is the product here? Here the missing particle is 1 beta. Here 23490 thorium, it produces palladium, and what? Here again a beta particle is emitted. Uranium 23892, and 1 helium is produced, and what is the product? Here thorium is the product, 23490 thorium, and the last one is it is beryllium 94, and the product is same, that is 94 beryllium. And what is this particle or ray? Actually, in this reaction, beryllium in excited state release the energy to form the normal beryllium, and this released energy is in the form of gamma ray. So here gamma ray is the product. So we have finished our chapter. If you have any doubt or you face by problem while going through my video, then please let me know right in a comment box. Hope you like it.